Hello everyone, welcome to Paymon Tech Media. In this video you are going to learn about binary number system. So first let's take a look at the word binary. When we talk about binary, looking at the prefix bi, what comes to our mind? I think of bicycle. So bi means 2. Therefore, binary number system is a base 2 system. In binary we have two symbols. We have 0 and 1. 0 means off, 1 means on. Therefore, in binary, we have only two numbers, 0 and 1, which is total of two numbers. That's why a binary number is a base 2 system. For every numbering systems, we do have place values. And by the use of these place values, we can quickly understand the value of that number. So first, I'm going to go ahead and put the place values. So this one all the way to the right, this is the place value position 0. And in the binary system, it is a base 2 system. So the base is 2. 2 to the power of 0 is 1. Any number to the power of 0, it's 1. Therefore, this is the ones place. Now moving one place to the left. This is place value position 1. 2 to the power of 1 is 2. And this one is place value position 2. So 2 to the power of 2 is 4. And this one place value position 3. 2 to the power of 3 is 8. This is place value position 4. 2 to the power of 4 is 16. And this is place value position 5. 2 to the power of 5 is 32. This is place value position 6. 2 to the power of 6, 64. This is place value position 7. 2 to the power of 7, 128. And so on. I could continue moving to the left and putting the place value position. So this one would be 8. 2 to the power of 8, 256. Place value position 9. 2 to the power of 9, 512. And so on. And here you probably noticed the pattern. Every time when we're moving to the left, it is multiplying by 2. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2, 16. And so on. So every time moving one place to the left, it did multiply by 2. Why 2? Because binary is base 2 system. So these numbers are the base numbers. And because this is a binary, base is 2. And these numbers are the place value positions. So here, as we can see, place value position at 0, place value position at 1, place value position at 2, and so on. And these numbers are decimal value. So where the decimal value is coming from, base to the power of bit position. For example, here bit position 0 gives us a decimal value of 1. This one is bit position 2, base is 2 in binary system, 2 to the power of 2, it gives us a decimal value of 4. And so on, as we can see here. So as I mentioned earlier, in binary we have zeros and ones. So let's go over one example of binary number. Let's say binary number of 1, 1, 0, 1, 0, 1, 1, 0. So this is one example of binary number. We have 8 bits, binary digits. So this is 1, 2, 3, 4, 5, 6, 7, 8. Out of these 8 bits, there are some of them being turned on and some of them being turned off. Now let's put the binary number in the place value. Going from left to right, so this is 0, 1, 1, 0, 1, 0, 1, 1. And of course, if we had more bits, binary numbers, we would just continue putting them in these place values. But in this case, we have only 8 bits. And that's why we have to go from left to right. So starting this 0, and this is 0, 1, 1, 1, 1, 0, 0, and so on, as we can see here. So these numbers are the binary number. Okay, so what is this binary number? Let's say if we want to convert it to a decimal number system, what do we have to do next? So if I put it in the simple word, we just need to add the ones that are already being turned on. In this case, 128 being turned on, 64 turned on, 16 turned on, 4 and 2 turned on. So we just need to add 128 plus 64 plus 16 plus 4 plus 2, and that's our decimal number for this binary number. Or in other words, it's basically 1 times 128 plus 1 times 64 plus 0 times 32 plus 1 times 16 plus 0 times 8 plus 1 times 4 plus 1 times 2 plus 0 times 1. So 1 times 128, that's 128, plus 1 times 64, that's 64, plus 0 times 32, that's 0, plus 1 times 16 is 16, plus 0 times 8, that's 0, plus 1 times 4 is 4, plus 1 times 2 is 2, plus 0 times 1 is 0. So in other words, we have 128 plus 64 plus 16 plus 4 plus 2, which 128 plus 64, that's 192, and 192 plus 16, that's 208, 208 plus 4, that's 212, and 212 plus 2, that's 214. So this binary number is equivalent to 214 in decimal number system. So if I put it in the simple word, basically we just need to add the ones that are already being turned on. In this case, 128 turned on, 64 turned on, 16 turned on, 4 turned on, and 2 turned on. 1 means on and 0 means off. So we just need to add the one that already being turned on. In this case, 128 plus 64 plus 16 plus 4 plus 2 gives us 214. So this binary number is equivalent to 214 in decimal number system. Now how we can convert this binary number to a decimal number system using the calculator. So let's take a look. I'm gonna go ahead and clear the screen. So first we have to change the view from standard view to the programmer view. And then we want to make sure BIN is selected. And as soon as we select the BIN for the binary, we can see only 1 and 0 being available. The rest of the numbers are grayed out, because in binary we have only 1 and 0. So what was our binary number? So we had 1 1 0 1 0 1 1 0. So let's put 1 1 0 1 0 1 1 0. And here, as we can see, our decimal number is 214. So this binary is equivalent to decimal of 214, which, as we can see here, 214. Now let's take a look at another binary number. Let's say they gave us a binary number of 11000101. So how many bits do we have here? 1, 2, 3, 4, 5, 6, 7, 8 bits as well. Again, some of them being turned on, some of them being turned off. So if you put the decimal values, you guys remember, start with 1, 2, 4, 8, 16, 32, 64, 128. Where do they coming from? Base, right? 2 to the power of 0. For this one, 2 to the power of 1, 2 to the power of 2, right? And it gives us these decimal values. Okay, so here what do we have to do? We just need to add the ones that are already being turned on. In this case, 128 plus 64 plus 4 and 1. So let's write down 128 plus 64, that's 192, plus 4, 196, plus 1, 197. So it should be 197. Let's take a look using the calculator. So again, we want to make sure the programmer is selected, and then BIN for the binary number. So we have 110000101. 110000101, and the decimal value number of 197. In these examples, I just used 8-bit binary number. What about if we have more than 8 bits? For example, let's say 110010110101. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 bits, for example. Some of them again turned on, some of them turned off. So here we can put the decimal values 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048. And again, as we can see, it kind of doubles, multiplies by 2 because of the binary number being base 2 system. And what do we have to do next? We just need to add the ones that are being turned on. In this case, 2048, 1024, 128, 32, 16, 4, and 1. It's on, as we can see here. So adding these decimal values, the ones that are already being turned on, we get our decimal value. So this binary number to that decimal value. Well, this was a quick overview of binary number system. Thank you so much for watching. If you have any question, please leave it in the comment section. If you like the video, please hit the thumbs up. And if you haven't subscribed to our channel, please subscribe. Thanks again and have a good day.